Hey everybody, welcome to For Food's Sake, the podcast bringing you down-to-earth dialogues about the food on your plate and its many impacts on people and the planet. My name is Matteo De Vos, and without further ado, let's talk about food. This week I talked to Pamela Ronald, a plant pathologist and geneticist at the University of California, Davis. Pam and her colleagues have received numerous awards for their work on submergence-tolerant rice. She's also very well known for her pragmatic but unique approach to agriculture that brings genetic engineering and organic farming together. Now in this episode, Pam and I talk about genetically modified organisms, or GMOs, although Pam prefers to avoid using the term for a number of different reasons that we'll get into. We address some of the criticisms commonly associated with the topic, the misconceptions and misinformation, and even brush on the issue of anti-GMO labels being synonymous to false marketing. We then take a more optimistic turn and look towards the future. How can genetic engineering help combat climate change? And Pam's own work in this regard is especially fascinating. I enjoyed talking to Pam and really valued the conversation we had in getting me to reflect and challenge some of my own assumptions on this topic. And I think I learned a lot, and I hope you will too. So without further preamble, here is Pamela Ronald. Pam, thanks so much for joining us on the show today.
Well, thank you. It's a pleasure to be here.
You're probably the scientist that's most widely known for publicly defending GMOs, genetically modified organisms. And for me, you've done some fascinating and inspiring work on plant genetics that are actively helping millions of people. And so in this talk, I'd really like to get into some of that and your vision of GMOs in the future and sustainability in agriculture. And also talk a little later about your book, Tomorrow's Table, and your belief that genetic engineering and organic farming, out of all things, can come together and in this kind of ecologically balanced way and help feed the world of tomorrow. But before we do that, I think maybe it's best if we just start from the beginning with a simple question. What are genetically modified organisms?
Okay, so first of all, I hopefully I'm not publicly identified with defending GMOs for a couple reasons. One, I am an advocate for sustainable agriculture using appropriate technologies, and modern genetic technologies can be one component in a sustainable food system.
Right.
And second, I avoid using the term GMO as much as possible because I see that generalizations about GMOs really don't advance the discussion around sustainable agriculture.
Right.
And the reason is that every crop is different, every trait is different, every geographic region is different. So I think the term is very ill-defined, and it's often used in a political sense, which is sort of meaningless in a scientific or agricultural sense.
Right. Okay, so yeah, I mean, that makes a lot of sense. I think GMOs not only maybe is it ill-defined, but it's definitely one of the most controversial and divisive topics, perhaps because it's so ill-defined. And what I find so interesting is that there's this real, public distrust in GMOs or in kind of anything that is genetically modified that persists, and especially I think in Europe, this is resistance that persists, and so I wanted to maybe get your opinion on some of the, some of the main criticisms that people have that are perhaps misconceived or that have kind of led to a public that's a little misguided or a little misled in terms of what GMOs are and how genetically modified plants could help in terms of sustainability. So maybe we could start by just talking about GMOs in terms of safety, and are they safe to eat? Can we, from a scientific perspective, and this is great to have you here as a plant geneticist, can we confidently state that there's, no long-term health effects, or what are the studies that have been done? Are there unforeseen side effects that we might not have accounted for yet? Is the science clear?
Okay, so I think you really have to back up because those are, again, using this term GMO, and you really can't generalize about a GMO. It doesn't really make scientific sense. So if you consider that everything we eat today is genetically improved in some manner, it helps put things in perspective. The only exceptions, there are a few exceptions. So, for example, I live in California. We eat Pacific wild-caught salmon, which is not genetically improved. We can go up into the hills and collect mushrooms that chanterelles are actually quite abundant around here. Those are not genetically improved, but virtually everything we eat, breakfast, lunch, and dinner, is improved. And so what does that mean? Well, there's many different types of genetic improvement. There is hybridization, which is mixing two very different plant varieties together, and that was described really a couple hundred years ago. There's genetic engineering of crops, which allows scientists to take a gene from one species, put it in another species. There's marker-assisted breeding, which use genetic technologies to introduce new genes into plants. And there's genome editing, which is another new method of genetic improvement that is a very exciting potential application. And the goal of all these different types of genetic improvement is to develop a seed that has traits that are useful for farmers and consumers. And then that seed is going to be grown in some type of farming system. And so it's really the combination of farming practices and seed that help determine whether a particular crop is going to advance sustainable agriculture. So if I give you a specific example, that might help your listeners understand what I mean. So there is a very successful crop in Hawaii that was developed using the technique of genetic engineering, and that's papaya.
Right.
So in the 1950s, there was a very serious viral infection that destroyed the entire crop on the island of Oahu, and that's because plants get viral infections, as do humans. And there was no way to control this disease, no organic method, no conventional method. There's nothing you could spray. So a local Hawaiian, a plant pathologist named Dennis Gonzalez, decided to try to protect the plant using genetic engineering. So he took a small snippet of a mild strain, a small snippet of DNA from a small strain of the virus, and he introduced it into the papaya plant. And that essentially immunized the papaya against infection. So that allowed growers to start growing papaya again. I think the genetically engineered immunized papaya produces 20-fold more papaya than the conventional variety. And so then you can realize immediately, I think, that that's very important for Hawaii papaya farmers and for consumers that rely on papaya as an important source of nutrients. But sometimes people say, well, I don't want to eat a gene from a virus, which on first blush makes sense. But if you think about it, if you bite into a papaya that's not genetically engineered, so for example, an organic or conventional papaya that's infected with the virus, you're actually eating 10-fold more viral protein. And that virus is not going to hurt you. It doesn't infect humans. But I think it allows a little bit more perspective, and that's why this papaya has been so important for farmers in Hawaii and has been widely accepted and consumed for 20 years. And about 90% of the papaya is genetically engineered, and it's also exported. That's what we eat here in California. And so not only has there not been any harm to human health or the environment, there's not even any scientific hypothesis how it could harm somebody. So I think this is a really nice example of a specific application of genetic engineering. And also, I should mention, it's in the public domain. So this is funded by the U.S. Department of Agriculture and distributed freely to farmers. So I think it's really important to think about specific examples, because that way you can advance the discussion.
Right, rather than more anecdotal. I mean, I'm thinking as well about the, I think it's Niger Taylor, the virus-resistant cassava plant in East Africa. I guess that's another example of genetic engineering being used to combat diseases.
That's a really important and exciting project. So cassava is a very important staple food for a huge number of people in less developed countries, and it's suffering from a virus infection that is really affecting the lives of subsistence farmers. So Nigel and his colleagues are trying to develop a cassava that's resistant to that virus. And maybe I should also mention that the process of genetic engineering itself has been used for more than 40 years. So it was first applied to production to produce insulin, which used to be harvested from pigs. Now it's produced in yeast. So most of the cheeses in the United States and some in France are produced using a genetically engineered enzyme. So this technology has been used for a very long time, and every major scientific organization in the world, including the European Food Safety Authority, has concluded that the process of genetic engineering is no more risky than other types of genetic manipulations. But each crop has to be looked on a case-by-case basis. So that's why I think it really is very difficult for consumers to understand what's going on if there's a lot of generalizations made, because it's not something you can generalize about and come to any conclusion.
Of course. And I mean, I think maybe then maybe if not directly a health concern, maybe some people have concerns, and that's an argument I keep coming across about, the herbicide use that around certain genetically engineered, and again, maybe I'm generalizing here, but I'd love to hear your opinion on this, but the idea that, we're using more herbicides, we're using more, in the case of glyphosate, we're using more herbicides when it comes to genetically modified crops like corn and like soybean, and I guess this kind of links, and we can talk about this a little later, but I think the fear that people have when it comes to genetically engineered foods is that it's very much intertwined with big business and with industry. But in terms of herbicide use, I mean, is that definitely a concern that, maybe the genetically engineered plant in itself isn't harmful, but the fact that it may be more resistant to pesticides encourages farmers to use more pesticides?
Yeah, so again, there's a huge number of issues that needs to be teased apart. So first of all, I think, the example I gave you of papaya, there are no herbicides involved, and there's no big business involved, right? So right away, I think people can see, that's too much of a generalization. And then also, there's different types of pesticides. So they're commonly broken into, for example, insecticides that kill insects, and herbicides that kill weeds. Right. So when it comes to insecticides, there has been really important advances in controlling insects without using chemical sprays. And that's based on an organic farming technique called BT. So organic farmers spray BT, so it's a microbially derived insecticide, and they spray it on their crops to control insect damage. The reason they use that is because it's non-toxic to humans and animals and very specific to particular pests. So it's been very successful, but there are drawbacks. So, for example, in Bangladesh, there's a very serious insect that will devastate the entire eggplant crop if it's not controlled. So farmers there are spraying some very serious chemical insecticides. And farmers there don't have access to spraying this BT because it's hard to access, it's expensive, and it doesn't prevent the insect from getting inside the crop. So what Bangladeshi and Cornell scientists have done, and again, this is a nonprofit public domain project, is to engineer this a gene encoding this organic insecticide into the crop itself. And farmers have been able to reduce their insecticide use almost down to zero.
Right.
And this is not new. So farmers in the United States have been using the Bt gene in corn plants for 20 years. And the U.S. Department of Agriculture has reported that farmers have reduced their insecticide sprays tenfold over that time, and that's due to the use of these Bt crops. So again, it's really important not to generalize because insecticides have massively been reduced all around the world because of this single trait, which it's also been used in cotton. It's been very important for farmers in cotton in India and China. So then there's another trait, which is called herbicide tolerance.
Right.
And these herbicide-tolerant plants, they can be developed through conventional genetic methods or genetic engineering methods. So again, different types of genetics can lead to crops that are tolerant of herbicides. So it's important to keep in mind that in the developed world, virtually all farmers spray herbicides to control weeds. Weeds is a major problem of all farms all over the world, whether you're a small farmer, a large farmer, or organic farmer, or conventional farmers. Weeds are probably the number one problem for farmers. So that's one reason farmers have used herbicides. But some of the herbicides that have been used in the past are considered to be persist in the groundwater and concerns about toxicity. You've probably heard of paraquat, which is an old herbicide that can be quite damaging. So farmers now have shifted to an herbicide called glyphosate,
right,
which is classified as non-toxic by the Environmental Protection Agency. But it's still a chemical herbicide, but it has properties that are more beneficial for the environment because it doesn't persist and it's less harmful. And so what many farmers in the United States are growing are herbicide-tolerant crops that they can spray the herbicide and still harvest their crop. And so whether or not, I think, again, there's this confusion with genetics. So if they're, a reasonable person might say, I don't want to spray any herbicide.
Right.
And that's fine, but I think it's important to realize that that's not genetic engineering. So if you remove genetic engineering, we already know what will happen because it's been reported on NPR and many other organizations. If you take away the crops that are genetically engineered, the first things farmers will do will substitute another crop that is also tolerant of the herbicide and keep spraying the herbicides. That's one consequence. The other consequence, there's been this sort of uptick in farmers growing what's called non-GMO crops. And these are particularly problematic because they're not certified organic. So in a certified organic system, farmers are not allowed to spray some of these herbicides. They're allowed to apply some others, but they're not allowed to spray paraquat and glyphosate. But these non-GMO crops, the farmers can spray whatever they want. And so what's happening is alfalfa farmers, for example, in California, there's a demand for non-GMO crops. Farmers are now spraying, going back to older and more toxic herbicides, such as paraquat.
To compensate for, right.
Yeah, so it's important to understand the benefit and risk, and also it's, I think, important to probably avoid anything called non-GMO because usually these are the least sustainable types of seeds used in the current agricultural system.
Okay, so I mean, in terms of in terms of big business, then again, is just a matter of over generalizing. I mean, I've read a lot of critiques about people saying that, regardless of the stance that we might have on genetically engineered plants, the reality remains that even if you have these, publicly funded projects in the developing world that are doing fantastic work, the majority of these projects are still being funded by, the Monsantos of the world, the Bayers, and that GMOs, they're not feeding the world. At best, it's more a PR campaign, it's marketing, and that really what they're doing is they're feeding, the fast food industry. That this is very much just an epitome
Matteo,
of right.
Yeah, maybe I can hold you off a little bit, and I think you need to reflect on the terminology again. So what happens, people get very upset and they start saying GMOs and corporations. It really advances the discussion if you focus on a particular crop. So
Sure.
Take papaya, for example. I think it's helpful for the audience to think about what they might like and dislike about the papaya. You mentioned corporations. There aren't any corporations, as far as I know, involved in the papaya.
But if we pick corn, for instance, or if we take soybean, I mean, the kind of quintessential examples. I mean, I'm playing devil's advocate here.
No. So let's talk. I think it's really good. We're going to advance the discussion if we let's talk about BT corn.
Sure.
In the United States. BT corn is sold by Monsanto. And where do you think organic farmers buy their corn?
I have no idea.
Monsanto. So organic farmers, like all farmers in the United States, buy their seed from for-profit seed companies that, whether we like it or not, and there's plenty of reasons to criticize, we have very large seed companies, and I think there's legitimate reasons to talk about why we might not want these large seed companies.
Sure.
But the status quo is that virtually every farmer in the United States, whether they're conventional, organic, genetically engineered, they're buying their seed from these companies because these companies deliver the seed that the farmers want. So these large companies, I think in California, Monsanto has the largest share of many of the organic seed because they're large companies, right? So they dominate distribution and selling of many of these seeds.
Sure.
So again, it's really important to break down what exactly is the question. A specific question, and that's the only way you can get a specific answer. If there's a lot of hand-wavies about GMOs, first of all, the term GMO is meaningless, so you can't advance the discussion. So I think that's really important to ask one question at a time and a very focused question. And my experience is that one of the issues is not whether or not people understand genetics. There's just a real sort of lack of knowledge about agriculture. And it's not surprising because there's something only like 3% of Americans, and maybe slightly more in France, are farmers. So you have misinformation and generalizations in the urban centers. And I think one of the things that agricultural scientists are trying to do to discuss these issues on a more simple basis, because most people really are curious, right? And
Sure.
They want to know, well, why would a farmer plant a genetically engineered seed? Well, you can ask them, if you go to a farmer, why are you planting BT crops? They'll tell you, because we can spray 10-fold less insecticide. It's not really that mysterious.
Sure. No, that's really interesting. I think, yeah, it's very important. And I mean, I'm to some extent playing the devil's advocate here, but of course, I mean, my understanding of this is quite limited. But to be more specific, and I guess that's part of the problem, is that, you know, those aren't necessarily always the sensationalist media headlines. It's easier to generalize, and if you're a curious public, it's easier to keep some of these matters more more black and white, I guess, and ignore, that a lot of the discussion is more in the gray areas. And I guess kind of shifting focus here a little bit, maybe on your...
Maybe I could just say
Sure.
one more thing about big business. There's been a lot in the news lately about this non-GMO project because they're putting this non-GMO label on everything, right? Even water and salt. And anybody that's familiar with biological systems knows there's no genes in water and salt. So the problem is consumers are paying a lot more money for this label that's meaningless. And it's actually illegal in Canada to do that because they're only allowed to place a non-GMO label is if there's a sort of genetically engineered counterpart. And so this sort of non-GMO labeling is really a problem for consumers because people see water and non-GMO water. In the back of their mind, they think GMOs are bad. I better pay twice the amount for this non-GMO water that's certified. But water is H2O.
Right.
There's no genes. And so the marketing, I agree, is just gotten completely out of hand, and it's really problematic for consumers.
Sure. And I guess that might be also part of the fact that I think a lot of people, and we can get into this in a second, they equate GMO with non-organic and non-GMO with non-organic. And so the idea maybe being that if it's non-GMO, there must be some kind of association with purity and with, it being organic and non-industrial and non-modified. And maybe that's why a lot of people are kind of moving towards these marketing trends and I guess kind of being fooled by them. It's interesting. I think even Mark Bittman, so the former New York Times chief food writer, he was in support of, I think, of food labeling himself. And so it's interesting to see how kind of far it goes and how many people can end up, I guess, being trapped in this generalization.
Yeah, and maybe just to clarify what you just said, in case your audience didn't understand your point, which is true, is that if you buy organic produce, so organic farmers are not allowed to use genetically engineered crops. So they are allowed to plant crops developed by radiation mutagenesis or chemical mutagenesis. They're allowed to plant grafted crops, which are two species mixed together. They're allowed to plant crops that have been developed in the laboratory. There's only one type of genetically improved crop they're not allowed to grow, and that's genetically engineered crops. So An organic farmer in Hawaii is forced to plant the papaya that's susceptible to the virus. So that's why if you buy an organic papaya, it'll have 10-fold more viral protein because it's infected. So, and that's, those are the standards both in the United States and in Europe for organic production. And there's some, you can read about that. So that's very clear. But non-GMO, and I should say, so organic production also has some other rules about not being allowed to spray. They're allowed to spray some insecticides, but many chemical insecticides they're not allowed to. Sure. Now, if you buy something non-GMO, all that means is that they're not genetically engineered, and it has nothing to say about food safety. And as we just discussed, they're allowed to just dump on the insecticides and herbicides. So if someone's concerned about chemical applications, they absolutely should not buy non-GMO products. Those are on the very bottom of the totem pole, and they're very over-marketed. So that's really important to avoid those.
That's fascinating. I think it'd be great to kind of look towards the future, and I think this is where your work really comes in too, and the work you've done with your lab on rice specifically being, tolerating floods and being disease resistant. So the idea of climate change in the future and where we're heading, and the kind of role that genetically engineered plants can play in mitigating some of these, not only kind of the diseases that we mentioned, but mitigating the climate effects that we're inevitably going to be facing. So could you tell us a little bit about the work that you've been doing in your lab and similar projects that are at the forefront of the food of tomorrow, I guess?
Yeah, so my lab does a lot of different type of genetic improvement. We use mutagenesis, we use genetic engineering, we use marker-assisted breeding. We're open to different technologies, and our goal is to develop rice plants that will help farmers in South and Southeast Asia. So rice, I've chosen to work on rice because it feeds more than half the world's people. And in particular, we're very interested in understanding which genes help the plant resist disease and confer tolerance to stress.
Sure.
So I have been involved in an exciting project where so one thing that considers 4 million tons of rice, enough to feed 30 million people, is lost every year to flooding. And these are farms where families are living less than $2 a day. So one of the goals of my collaborators and I were to try to develop rice plants that could withstand flooding. So most rice varieties will die if they're submerged for more than 3 days. But there is one ancient variety that can withstand flooding for 2 weeks. So my colleagues and I isolated that gene, and the gene we named submergence-tolerant gene. And that gene then was introduced into varieties favored by farmers in Bangladesh and eastern India using another genetic technique called marker-assisted breeding. And last year, 5 million farmers grew those rice varieties, and they saw a 3-fold increase in yield after flooding.
Wow.
And this is, one of the kind of really important issues is because as the climate changes, the Intergovernmental Panel on Climate Change is predicting more and more flooding. So these are some of the traits that scientists all over the world are very interested in trying to identify. How can we make a plant drought tolerant or flood tolerant or salt tolerant to really help farmers access new seeds that are resilient of changing climate.
That's really fascinating. I mean, I think these are the type of, anecdotes people should be hearing about more when it comes to genetically engineered plants. And I think especially from, climate change and the urgency that we have now, I think one of the things people have to maybe realize is that we've really lost the luxury of time, right? To sit here discussing or to just use conventional methods of breeding resistance to certain diseases and climate change that would, potentially take decades. And one of the things that I find really exciting about your work and similar work is that, it's really at the forefront of science, and it's kind of pushing those barriers, and it's offering, concrete, real solutions in places like Bangladesh and southern India to problems like flooding.
Yeah, and I think I would say that's true of most agricultural scientists. We work with farmers. Farmers are very practical-minded, empirical testing. They want to plant a crop that uses resources efficiently, reduces toxic inputs, and produces enough food for the village, right? So
right.
As an agricultural scientist and a farmer, we're very attuned to practical outcomes.
Yeah. Speaking a little bit more about yourself, and I found it so fascinating to see that your book is all about, the future of tomorrow's food, but from a very interesting perspective where you and your husband, he's an organic farmer, where you kind of bring genetic engineering and organic farming together. And I think that's a great way to finish this talk, because it's putting two things together that most people would, like we mentioned, would never associate and would never put together, the idea of the genetic engineering and the organic farm on the other side. So could you tell us a little bit more about your book and what your vision, I guess, is for the future of food and the future of organic food?
Yeah, sure. So as I mentioned, organic farming, to be certified organic, a farmer is not allowed to grow genetically engineered produce. So, I don't think it's worth forcing that. And I think what we try to do in the book is talk about the other 99% of global agriculture,
right,
and try to use the best approaches to advance sustainable agricultural systems. And I think it's very clear from many years of studies that, you need to really have a very ecologically based farm to enhance sustainable agriculture. For example, rotating crops are important, planting a diversity of crops, and then also use the best seed available. And that seed may be a seed that is genetically engineered, for example, for viral resistance, or maybe it was developed through marker-assisted breeding for flood tolerance, or maybe it's a hybrid that has high yield. There's many different types of seeds, but the seed and the farming system really go together, and that's really quite important. And so what we hope to see is more and more farmers moving to more efficient, sustainable farms using the most appropriate technologies. And I think we are seeing that. There's been a lot of changes just over the last 20 years, which have been very, very important on farms around the world.
So that was Pamela Ronald. Before we ended our conversation, Pam said one more thing.
I really think the most important thing is not to generalize. And even if people could just avoid using GMO and talk, as you did, well, what about herbicide-tolerant crops? That's a really important question. What does it mean?
Right.
Or what does it mean to use genetically engineered papaya? Because then it allows the consumer, who's really very far removed from the farm, to understand why the grower is making the choices they have.
Exactly. That's what this podcast is all about finding out more and reaching out to the people that are working in the field, so to speak. Thanks so much.
Great. Yeah, sure. Take care.
So there you have it. A little less generalizing can do us all some good in so many different contexts, including GMOs. If you'd like to know more about this approach that Pam takes, including her take on genetic engineering and organic farming, do check out our book. It's called Tomorrow's Table, Organic Farming, Genetics, and the Future of Food. And you can also check out our TED Talk, which I'll add to the description below. And I'll add another couple of links on GMOs that I thought were interesting to keep the conversation going. That's it for now, guys. Next week, we'll be back with another Learn by Doing episode. For those of you who don't know, Learn by Doing is a For Food's Sake initiative where we practice what we preach in sustainability. It's about taking that extra step and not just talking about sustainability issues, but actually practicing them and living them. And so next week, we'll be talking about Merit 360, which is a year-long world merit program that I'm currently involved in of 360 global citizens together developing a set of action plans to tackle the United Nations Sustainable Development Goals. And so the Sustainable Development Goal that I'll be focusing on is number 12, responsible consumption and production. And just to keep things interesting, I'll be recording from Mozambique. See you next week.